Good afternoon everyone, and welcome to another Adventures in Haskell. Today we are going to look at adding command line parsing to our BF interpreter so that later we can add all sorts of different functionality to it. There are two useful bits of Haskell module that you're going to need. So if we nip over to Google and have a quick look, then the first package that you're going to need to look at is system.environment. That's in the base libraries, and that has a really important function, getArgs, which will give you back the command line arguments, not including the name of the program being executed. And then system.console.getOpt, which will give us a simple getopt-like command line parser, which we're going to then use for building our command line. So let's head on over and import both of those modules. So system.environment and system.console.getOpt. Oh, needs a capital O. There we go. Now, in our main function, we're not actually given the arguments. So one of the earliest things that we can do is we can say argv comes from getArgs. So now we have a list of strings come out of getArgs for us for our argv. We're going to want to be able to parse those, so let's put together a little bit of an options section of our file. If we go back to Google and we have a look at system.console.getOpt, then you can see that getOpt takes an arg order, option descriptions, list of strings, and then returns a tuple, and that tuple is the option arguments, the non-options, and a list of error messages. Seems fairly simple. If we look down, then we can see things like, arg order is require the ordering, permute, or return in order. And what that means is that either we stop option processing the first time we hit a non-option, like a file name, or you can freely intersperse them, or we wrap up non-options into option values using a function that takes a string, which is the non-option, and returns an A, which is our option type. So what we can do is we can either process everything in one go, or we can allow it to permute the non-options into options, or we can allow it to permute the ordering, and who cares. Permute is the most sensible option for us because we're going to be looking at writing a compiler type interface. And then we have our option descriptions, which take a list of short option characters, a list of long option strings, a descriptor, and then an explanation for the user. And there are two really good examples. The first one here, which gives us back flags such as, is it verbose, are we asking for a version, is it the input file or the output file or a library directory, and so on. Or we have a mechanism for transforming an options record, which gives us back a nice simple record that we can use. We're going to go with the options record approach because personally I prefer it. So let's go ahead and write ourselves an options type, and let's derive show just because it's handy. So the first option that we're going to have is probably an action. No, let's have help. So if they ask for help, we can tell them. If they ask for a version, we can tell them. At the moment, we could either parse and output the BF instructions. We could parse and execute a BF program, or we could do nothing of use. So let's, in sort of true compilery style, have an output action, and our output action will either be to run it or to compile it and output parse it and output the parsed version. So let's have action, and let's just go ahead and define that. So data action is either going to be parse only or interpret. So there we have our three things. We can ask for help, we can display a version, or we can choose the action. Let's now have some default options, which will be an options type. And let's just tidy that up a tad, and opt help will be false, opt version will be false, and opt action will be interpret. So there we go. We've now given ourselves some default options. So let's start writing our options descriptions for getopt. If we go back to Haskell, then you can see that they define, in this example, options is an option description, a list of option descriptions that take option and return options, and that's this type that's been defined up here. And the reason for that is because this is the type of the function which is going to be handed every argument that occurs, and we'll need to do something with it. So let's do that now. So our options will be a list of opt descriptions of options to options. And oopsie, the first option will actually steal pretty much the entirety of that, because it should just work directly. I can operate my editor today. It's a skill of mine. Now, obviously, it's not actually verbose that we're going to be doing here, but rather version. And there we have our first option. Now we're going to take that entire thing and duplicate it, only with a comma there, and we're going to put help. And there we have our first two options. And finally, for action, well, there's going to be two options. There's either going to be let's say -c, which is going to be, actually let's say it's -p for parse. And now this doesn't take an argument again, but in this case opt action will be parse only. And that will parse the input, and for completeness, even though it will be the default, we'll say -i for interpreting it. So there we go. Now what we could do with is we could do with a function which, when given a list of strings, will give us back a result of parsing it. Now the example that they use here is an IO function that uses user error and IO error and all of that pain. Personally, I dislike that dramatically. I think that we can do much better by using an either. So what we're going to do at this point is we're going to say that our BF options will be from a list of strings to an options and a list of strings, and the options are going to be the output of our options parser, and the list of strings will be the result, basically the non-option values that come back from us. So let's actually make that happen. BF options of an argv is get opts. Sorry, again I said permute is a good idea, and we're going to use our options that we have and an argv that we've been given, and that can basically produce either no errors or some errors. So let's just write those two cases in: the options, the non-options, and no errors, or the don't care, and the errors. Let's put some spaces in because they look a bit neater, and line that up. So we've got our two cases. If we nip back to the Haskell example here, then we can see that they're doing concat errors with usage info header options, where header is this example, this text here. So let's thieve that as an idea, and let's extend slightly our code. So we are either a string or that lot, where header is usage BF there we go, nice and simple. And actually we can go one step further with our examples, because there should be exactly one non-option coming back for the file name. So let's be quite clear about that, and let's get rid of that list there because we don't want it. We should have exactly one file, which is the file name that we're going to interpret. So let's deal with our error cases first, and our error cases are going to be left of concat errors and usage info of header and options, which is pretty good. If there was either 0 or 1 files, then we're going to say exactly 1, and we're going to define exactly 1 to be there must be exactly 1 BF input file given. And on our success case, this is where it gets a little more complicated. It's clearly going to be a write, and the non-option is our file name, but what comes on the left hand side needs to be acquired by this mechanism. Seems a bit strange, but it does work, and basically we just paste it in here and everything is good. Now this fold al flip id looks a bit strange, so let's just take a moment to explore what's happening there. If we fire up GHCI and we look at the type for id, then it's A goes to A, and if we look at the type for flip, then we see that it's an A goes to B goes to C goes to B goes to A goes to C. Now when we apply flip to id, then what we get is a B goes to C goes to C, which gives us, is a little bit closer to what we want, which is an A goes to A goes to A goes to A, and in fact that would just be a specialization of the B goes to B goes to C goes to C. But how does this happen? Well, the id could actually be $, and that perhaps makes a little bit more sense. $, is our application, and $, takes an A goes to B and an A and gives you a B. So if we think of id again, as A goes to A, and we specialize A to be an A goes to B, then what we get is that id can be an A goes to B goes to A goes to B, which, as you can see by Haskell's currying, is A goes to B goes to A goes to B, which is exactly the signature of $. So id and $, can behave pretty similarly under the right circumstances, which is why flip id and flip $, look the same. They take a thing and a function that takes that thing and gives you back a new thing, and it will give you that new thing. And that's perfect for fold L, which needs an A goes to B goes to A, and an A, and a list of B, and it gives you back an A, which is why when we fold L flip id, we end up with, we take an A, we take a list of A to A, and we return an A, which is exactly what we need to take our list of functions that mutate an options object and our default options and give us back our processed options. So if we go back to our code here, we now have code that can process our options and give us back either an error or success or failure. If we now get that by saying case bf options of left e, well, we can just raise that immediately. In fact, I'll tell you what, let's change this background. Instead of an either string options, let's produce an IO so that we can just IO error or user error. I was going to be nice and neat use either, but actually it's going to be neater to just do it manually. And we're going to need a return there just to make it happen. So we can now say that opts and file fname come from bf options of argv. So that will work, and we can change hello.bf there to be fname, and providing we don't actually care about the options being acted on, we should now be able to run our thing with a file. So if we run GHC of our new bf.hs, we get there must be exactly one file given. We should probably put a new line or two at the end of our errors, and then we get a convenient usage and the arguments. So that's good. Let's go a little bit further and let's print opts at this point, because then we can get our options out. So if we run examples hello, then we can see here's our options. Opt action was interpret, and help was false, and version was false, and we actually ran with examples hello.bf because we got our hello world. So let's just extend our main function ever so slightly and go from there. So here is a little bit of the option parsing rewritten slightly. I now return a maybe string here. I return a nothing from this option, this failure mode where it's not exactly one file name, and that allows me to deal with the situation of asking for the version with not specifying a file name, which is kind of important, and it allows us to process through. So the only thing that's left for us to do is to handle the situation of do we interpret or do we just parse. So that obviously needs to handle in here, and basically we can say when opt action on ops. Actually, let's go a little bit further. Let's capture that out here. Let action is opt action on opts. When action is parse only, in fact I can go just do it with if action is parse only, then put strlen, well, we just go print instructions, else eval state t. Possible fix, add an EQ for action. I don't know if you recall, but we didn't actually support EQ there, and now it works. So if we say dash dash parse of that, then we get our parse output, and if we say dash dash interpret, then it runs. So we've extended our BF code with a simple command line parser, which lets us look for version and help, to parse or interpret, to handle the file name that comes back as well, to report failures, and to output all of that nice and neatly into our code. Next time we'll look at extending BF a bit further with some more stuff that will need further command line options. Bye for now.